Hello, hi guys, myself Mubarak. So, welcome to Chemistry Byte. So, in this lecture, we are going to discuss the previous year questions which was asked in CSR, UGC-Net, JRF examinations related to the Birch reduction. So, coming to the first question, you can see here. So, this was the question asked in December 2011. The measured product A and B in the following reaction is, here they had given one anisole type of compound. They are reacting with a Birch reagent to give the product A. A is further reacting with meta perchlorobenzoic acid, so one equivalent of meta perchlorobenzoic acid to give the product B. So what is A and B? Okay, so we'll start with the anisole type of compound. So first, if I start with the anisole, so you can see here. So this, when I am reacting with the Birch reagent, that is lithium in presence of liquid ammonia and the protonating agent like the tertiary butyl alcohol. So what will happen here? So this Birch reagent will reduce an aromatic compound partially to cyclohexadienes. Here you are having the two substituents, and these two substituents are an electron releasing group. So both are electron releasing group. So this is the plus M group and this is the plus I group. So if you are having the plus I or plus M group on aromatic ring, you will get a cyclohexadiene in such a manner that these groups will get attached to the double bond. So product I will write like this. The 6-member ring will be as it is, and here you can see you are having the methyl, and here you can see you are having the methoxy. It is clear that methyl should be attached to the double bond, and at the same time methoxy should be attached to the double bond. So parallel to this double bond, you have to write the another double bond. This is the product A. This is product A. So further A, they are reacting with. Further A, they are reacting with what? They are reacting with metachloroperbenzoic acid, MCPBA. They have took only one equivalent. So what is the role of metachloroperbenzoic acid? So metachloroperbenzoic acid is a reagent used particularly for the epoxidation. So it will convert an alkene into an epoxide. So here you can see you are having the two alkenes. So one alkene was attached to the methyl, another alkene was attached to the methoxy. So which alkene will get epoxide, will convert into epoxide in this reaction? So that alkene which is electron rich will get convert into the epoxide. So electron rich alkene, so which double bond is having the electron rich, so more electron density, that will convert into an epoxide. So here you can see this double bond is attached to the methyl, so which is plus I group, and this methoxy is the plus M group. So we already know that mesomeric effect dominates the inductive effect. So then electron rich double bond is this double bond. Okay, so you can see here the electron rich double bond is this double bond. This double bond will get epoxide, will convert into epoxide now. So you can see here the 6-member ring is as it is there, and here double bond which is attached to the methyl was not converting into epoxide, and here methoxy will not change, and wherever this double bond was there, so this double bond will convert into epoxide. So this is the product B. So first of all, when you are reacting this with lithium aluminum hydride, you got the product A here, and this, when I am reacting with metachloroperbenzoic acid, I got the product B. So you can see in the options which is the right answer. The right answer is B. So B is the right answer. A is this compound you can see, and B is this compound. Coming to the next question, this is almost is the same question even asked in June 2012. Just they have changed the way of representing the molecule. If same structure it is. If I am starting with anisole derivatives like this, you can see the metamethyl anisole. Okay, so Me means methyl it is, and meta to that position you are having one methyl group. So first I am reacting with lithium in presence of liquid ammonia and the protonating agent like tertiary butyl alcohol. So what it will do, it will reduce an aromatic compound into cyclohexadienes, and here you can see both methoxy and methyl, so both are electron releasing groups, so both should be attached to the double bond. So how you will get the product? Suppose you can see here this methyl double bond I have written here, so another double bond should be written here. This is the product. So this further they are reacting with the metachloroperbenzoic acid. Just now I have said, so metachloroperbenzoic acid is used for epoxidation of an alkene. So alkene to convert into epoxide, this will be used. So where epoxidation will be happened? So epoxidation will be happened in electron rich double bond. So you can see here, so between these two double bonds, so which is the electron rich, the double bond which is attached to the ether, that's the electron rich double bond. So the product is this. So the double bond which is attached to the methyl will be undisturbed, and whereas the double bond which is attached to the methoxy will be converted into epoxide. So the right answer, this is the final product. So which is the right answer? Right answer here is the option C is the right answer. So coming to the third question, you can see this question was asked in December 2012. Pyridine, first they are reacting with the Birch reagent. So next for the product, whatever you got, the further they are reacting with the water in presence of acid medium, they are doing the hydrolysis. Next they are reacting with the alkaline medium. So here you should know the three topics. First one is what is the role of lithium in presence of liquid ammonia and tertiary butyl alcohol. So here this reaction is the Birch reaction. It is the Birch reduction. Birch reduction. So what about the second? So this is the hydrolysis of the amine. So what is the role of water? Okay, so here you can see this concept name is hydrolysis of enamines. Third reagent is an aldol condensation reaction. Third reaction is an aldol condensation reaction. So we'll start with what is its name? You can see it is an 2,6-dimethylpyridine. I'll start with 2,6-dimethylpyridine. So when I'm starting with 2,6-dimethylpyridine, so I'm reacting with a reagent, Birch reagent, lithium in presence of liquid ammonia, and the protonating agent tertiary butyl alcohol. So what will be the product? So it is clear that it is an 1,4 hydrogenation. Okay, where it will get hydrogenated? Very simple. One hydrogen will be here. So one hydrogen is here, so another hydrogen will come on the nitrogen, so you will get this structure. Okay, so what I added? We have added the two new hydrogens. So one hydrogen you have added on the nitrogen, so another hydrogen we have added on the carbon atom. So you can see the 1,4 dihydrogenated product. So this you can see what you have got. We have got an enamine. So this is an enamine. So why I am calling it as an enamine? Because here you can see double bond is there. It is an ene, and here you are having the amine. So this is called as an enamine. So enamine on hydrolysis with water in presence of acid medium. The first step, this enamine will accept the proton. Okay, so in detail we'll explain about this. You can see here this pi bond will get polarized here, and this carbon will accept the proton. At the same time, the lone pair of electron on the nitrogen will get polarized to this carbon. So finally you will get the structure like this. You can see here, and nitrogen is there. On nitrogen you are having the one hydrogen atom, and here you are having one methyl, and this double bond was undisturbed, and on this carbon you have got one new hydrogen. Okay, this hydrogen was donated by the acid, and here you are having one methyl group. So after donating the proton, so what happened? You got one double bond here, and because of 4 valency on the nitrogen, so you'll get a positive charge on the nitrogen. So what is the next step? Next step is the attack of water on this product. So next step is, if you are having the water, okay, so okay, so H2O I have took. So water is having the lone pair of electrons. So how it will attack on this? Very simple here. This pi bond will get polarized on the more electronegative nitrogen atom. At the same time, oxygen will bring its lone pair of electron and attack on the carbon. So let us write the structure. What you will get here? Nitrogen will become neutral, and it will have one hydrogen on this, and this double bond is unchanged, and at the same time here this carbon was attached to the methyl and also you are having one water molecule here. So now because of 3 bonds on the oxygen, so oxygen will get the positive charge, and here this carbon you are having one proton. So what is the next step? Next step is very simple. So this water loses the proton and it will become an OH here. Okay, you will get the structure like this. On nitrogen you are having one hydrogen here, and here you are having one methyl, and oxygen will convert into alcohol. Next step is the degradation of this ring. You can see here this proton will give its 2 electron to the oxygen. At the same time, so what will happen here, you can see this 2 electron between carbon and the nitrogen will get polarized on the nitrogen atom. So this nitrogen atom will accept the proton which is present on the oxygen, and you will get the product like this. So it's a double bonded nitrogen. Here you are having one hydrogen and new hydrogen was came here, and here having one methyl, and so it will convert into what? So it will convert into an aldehyde. Okay, so this we got at the last. So one you got a methyl ketone, another side you are having the enamine. Okay, so this part you can see this complete part is an enamine part. So this enamine part again will react with a water in presence of acid medium, and that enamine also will convert into methyl ketone. The same mechanism what I have explained before, the attack of the proton and attack of the water. Okay, so finally you will get this structure. So you can see here, so 2 ketones you got. So after this what happens? So this is reacting with KOH. So this reaction name, what is the reaction name? So it is an aldol condensation reaction. So here in aldol condensation reaction, so both ketones are present here. What will be the product? One of the ketone let us convert into an enol. Okay, so you will get the structure like this. First of all, one methyl ketone, let it be unchanged. So another methyl ketone I have converted into the enol. Okay, so this enol, when I am reacting with the base like the KOH, okay, so here this hydrogen will come out in form of the H minus minus H plus to form the enolate ions. Okay, you can see here one side you are having the methyl ketone, so another side you are having the enolate. So enolate ion like O minus. So now what happens in this reaction is this O minus ion will attack on the carbonyl carbon. At the same time pi bond will get polarized here. There is the ring closing. There is the ring closing was happening here. Okay. So total number of rings. Total number of rings you can see. So one methyl was present here, and on this you are having one OH, and at the same time, okay guys, so at the same time here what you will get a ketone like this. Okay, so here you got one aldol. So this aldol, further here you can see this alpha carbon having one hydrogen and this beta carbon is having the OH. There is the removing of the water molecule, so you will get the dehydration, and you can see the product here. You will get unsaturation here, and methyl is present here, and double bond. So this is the final product. So you can see what is the right answer. The right answer is, which is the right answer? The right answer is the B. So with this we have discussed the previous year questions. So still some more questions are there guys. So in the next lecture we will discuss about those questions.